Assalamualaikum and a very good evening. I bid to Sinazri. So today our team, which is consists of me, Nur Hidayatullah, and also Sophia Kong, will present about the report issues on the production of gasoline using the high-temperature Fischer-Tropsch. So for this report, we will talk about the research problem, methodology, the literature review information that we get, and also we will talk more about our result and discussion part, and also the we will conclude the research. So for the next part, we will talk about the research problem. I will give to Sophia to explain more about the research problem and the rest of the slide.
Okay, thank you, Daya. Okay, I'm gonna explain about the research problems in this study. And because the demand of the road vehicles fuels, which is gasoline, is increased, this is because due to the pandemic, COVID-19 happened in Malaysia, then only interstate travel is allowed at this moment. That is why Malaysian people prefer driving rather than using the domestic air travel with their own vehicle, and this cause the driving activity is increased. And the aim of the study is to identify the effectiveness of the HTFT process to generate more quantity of gasoline. There are three objectives that we have three objectives that need to be achieved in this study. The first objective is to study the process of FTS process by doing the literature review. And second objective is to develop the process flow diagram and determine the mass and energy balance by collecting data. The third objective is to suggest ways to improve the effectiveness of the HTFT process in producing gasoline. And I'm gonna present about the methodology that conducted in this study. The first stage is identifying the process, the commercial process in producing the gasoline, which is the high temperature Fischer-Tropsch process, is chosen to do the research in this study. And the second stage is the literature review, that all the information that needed in this study is collect or gathered by reviewing the journal article, research and research paper. And the third stage is the collecting data, which collecting the data of the mass and energy balance of the HTFT process. The first stage is to do the programming. The mass and energy balance is developed by doing with the help of the programming Excel spreadsheet. And the last stage is analyzing and interpreting the data. The process of the HTFT process is discussed in detail, and the mass and energy balance is developed, and the way to improve the HTFT process in producing the gasoline is suggested will be discussed later on. Okay. Thank you.
Okay, for the next part, I will talk about the knowledge that I've gained from the literature reviews. For the first one, I'll talk about gasoline. So gasoline, which is we all know or we call it as petrol, is a petroleum little product that consists of mixture of hydrocarbon. So the main function of this gasoline is it's used as a fuel in internal combustion energy. So in Malaysia, the most common gasoline that we use is the RO 90 and also RO 97. This is used for our car engine. So based on this slide, we can see that this chart, a bar chart of the production of gasoline in Malaysia. So we all know that Malaysia also produces a gasoline. So this table, this chart show a Malaysian production of gasoline from the year of 1986 to 2014. So for this period of time, the production average value is 71.66 thousand barrels per day. That means one day we can produce almost 71.66 barrels per day. And then for the minimum production, it's 25,000 production, while the maximum production is 118,000 of barrel per day. So the next one is the gasoline consumption in Malaysia. We all, as I said just now, the famous gasoline that we use in Malaysia is around 95 and also around 97. So for this table, for this graph, we can see that the gasoline product consumption in Malaysia from the year of 1918 to 2017. So from this graph, you can see that the average consumption is about 133.88 thousand barrels per day, which the highest number is in 2017, which is 300,000 barrels per day, while the minimum number of the consumption is 38,000 barrels per day, which is in 1918, which I think due to not much vehicle on that time. So next, I'll talk more about the Fischer-Tropsch synthesis. So Fischer-Tropsch synthesis is the process of transforming the mixture of hydrogen and carbon monoxide into the hydrocarbon using a specific catalyst. So Fischer-Tropsch synthesis is unavoidable production of hydrocarbon, and also it release high quantity of heat since it is an exothermic reaction. So as we all know that Fischer-Tropsch is divided into two types. So the first type is the low temperature Fischer-Tropsch, HTFT, and the second type is high temperature Fischer-Tropsch, HTFT. So for these research, we focus more about the high temperature Fischer-Tropsch. So this is the general knowledge about the high temperature Fischer-Tropsch. So as I said just now, Fischer-Tropsch process is an exothermic reaction. So when exothermic reaction will produce stream, which it produces steam, which this steam had to maintain the temperature in this process. So for high temperature Fischer-Tropsch, the temperature that we use is from 320 to 350 degrees Celsius, and the pressure of this process 25 bar, or we also can use the slightly higher bar, slightly higher pressure. And then for high temperature Fischer-Tropsch, we'll use the iron-based catalyst. Okay, next we also collect some data about the mass and energy balance. So this is the basic equation of mass balance, which is the input plus generation minus output minus consumption is equal to accumulation. So the general equation for energy balance is the difference of internal energy plus the difference of kinetic energy plus the difference of potential energy is equal to heat transfer to work done. So the difference is from the final minus the initial. Okay, this is like a general overview about the Fischer-Tropsch synthesis. As you can see that in the graph, it is divided into two, low temperature and high temperature. So at the first one, the feed of our Fischer-Tropsch is, it can be a coal, natural gas, or biomass, and also we have air, oxygen, and also steam. So for our research, we will talk more later. we have our own block diagram. So first, the feed will go into the gasifier, and then after that, go to the gas cleanup and conditioning. It will produce a clean gas, which is H2 and carbon monoxide. And then they will split to the low temperature and a high temperature. So as we can see in the table, for the lower temperature, they will go to slurry or tubular reactor, and then it produces wax, which then the wax will undergo hydrocracking and result in producing diesel. While if we go to high temperature, they will go to CFB or FFB reactor. Then it will produce olefin, which is C3 to C11, which is slightly lower than wax, wax is more than carbon 20. So the olefin then will undergo either oligomerization or isomerization or hydrogenation to produce gasoline.
Okay, this is the block diagram of the high-temperature Fischer-Tropsch process. So I'm gonna explain more further on the process descriptions. And the first is the ASU, which is aspiration unit, will supply the pure oxygens to reduce the inert gases in order for the gasification later. And in this process, coal is as the feedstock, and the water and pure oxygen will delivered into the gasification. The raw syngas is produced, which is mean that the syngas is still contain the contaminants, and the raw gas will deliver into the water gas shift and undergo the water gas shift reaction where the carbon monoxide react and the water will convert into the hydrogen and carbon dioxide and will produce the shift gas, which is stream number 5. And then shift gas will enter acid gas removal unit. In this reactor, in this process, the shift gas will the shift gas will be cleaned by removing the contaminants such as sulfur, hydrogen sulfur, to produce a more clean syngas later on. And the carbon dioxide is the byproduct, which is the stream 6, and stream 7 is the cleansing gas. And the cleansing gas will, which is free from contaminants, will enter the HTFT reactor to produce heavy oil, light oil, hydrocarbon condensate, and stream 8 tail gas. And among all the products, the light oil is more valuable than the heavy oil because it requires less energy in producing the gasoline and it's more valuable. So lastly, the tail gas, which is stream 8, will enter the combined cycle reactor to produce electricity. This is because as the HTFT is the exothermic and will release heat energy and cause high temperature. This is to control the temperature in the reactor. And this table shows the number of streams and the stream name of the previous block diagram.
So this is the mass energy balance for the high temperature Fischer-Tropsch. So you can see, like just now, Sophia have been introduced to the stream number and stream name, and she also talked more about the description of the HTFT processes. So as we can see, for the mass balance, we will use the flow. For the first two stream, we will use the flow rate in kilogram per hour, and for the next 5 stream, we will use a flow rate using the unit of kn cubic per hour, and then for the last 3 stream, which is the stream of the production, we use the unit of barrel per day. So because of that, it is a little bit difficult to determine the mass balance due to its different units. So next, for the energy balance. So for the energy balance, we will use the low heating value in the megawatt unit. So actually, low heating value is used to determine the energy input of the stream. So as you can see from the table, we simply use the lower heating value to determine the energy balance by using the MW megawatts unit. So next, I'll talk about the thermal efficiency. So as you can see at the bottom side of the table, it states about the thermal efficiency. So first, as I said, the feedstock of our production is coal. So we can see from this table that coal, uh, as you can see from the table, the coal turned into gasifier, it's 100% of efficiency, thermal efficiency, which means almost all of the coal is turned into the gas in the first stage. And then for the liquid product, the thermal efficiency is 41.1% of percent, and then the power export is 5.02, which is a little bit low. And then the overall of the thermal efficiency turned out to be 46.1, which is a little bit disappointed because it's not even half of the percentage.
Okay. Um, I'm gonna after Hidayah has been explained about the mass and energy balance that just now of the process, and there are few ways to improve the effectiveness of the HTFT is recommended. First is applying the Sasol Advanced Tool reactor, SAS reactor. From this table, it shows that more clear that why SAS reactor is using rather than CFB reactor, which is circulating fluidizing bed reactor. Okay, in from what we can see, the pressure in the SAS reactor is approximately 20 to 40 bar. It means that the reactor can withstand high pressure rather than CFB, which can only uh, withstand 25 bar. And the both reactor can operating temperature about 340 degrees Celsius. And if using SAS reactor, the ratio of the catalyst over gas is much more higher than the CFB reactor. And the energy efficiency of the SAS reactor is more higher than the CFB reactor because the cooling coil area in the SAS reactor is more than the CFB reactor. And beside that, the advantages of using SAS reactor is the cost for the tail gas recycle recompression is low than the CFB reactor. And apart from the CSS reactor can tolerate the higher level carbons in the catalyst, and this increase the rate of carbon. and this reduces the rate of carbon formation and decrease the consumption of the catalyst. And besides that, the SAS operation of the SAS is more easier than the CFB reactor, which is much more complicated. And this is why CSS reactor is used in order to improve the effectiveness of the HTFT. And the second ways to improve the effectiveness of the HTFT reactor is using the heat exchange remover. This is because if using the heat exchange remover, the 30% of the oxygen consumption can be conserved and increase about 4% of plant thermal efficiency of the HTFT. And
in conclusion, the objectives is archived and the aim of study also accomplished. So in this project, the light oil is used for gasoline is produced. You can see that for the production of gasoline, based on the table, it produces 34,070 barrels per day for the high temperature Fischer-Tropsch. And the overall efficiency of the HTFT process is about 46.1% using the energy balance theory. So we also can improve the effectiveness of HTFT process by using the SAS reactor and also use the heat exchanger reformer. So that's all for our presentation. I hope you have a great day and stay safe. Thank you.